Ladies and gentlemen, please welcome Vice President, Infrastructure, Google, Eric Brewer.
I get 4 chairs. That's pretty cool. I can just sit in all of them. Take some turns through these. But I think it's better if I stand and walk around. Have more energy that way. So I want to talk about building a higher cloud. And what I really mean by that when I dig in my sleep at night, thinking about where I want us to go, I really want us to see us separate applications from infrastructure. So the good news is, you guys already solved that problem. We can go home. Cloud Foundry does do that in an important way. But I actually think that we can broaden this view. So typically, you think of the Cloud Foundry as a platform as a service, and that because it's a bit more abstracted, it gives you a great developer experience. But it is opinionated. It has some choices on language, like you might prefer Java, for example. And it tends to have a target area that it's particularly good at, and this is true for all kinds of domain-specific PaaSes. The alternative historically has been infrastructure as a service, where you really get very little direct developer support. You get your VMs and your network and your disks, and they're not even file systems, they're actually just disks. And sure, you can build anything with that, but it's kind of a pain. So for example, who's going to patch the OS for security stuff? That's kind of on you if you use that level of abstraction. And so what I've been playing with for quite some time, and I think this is a very fruitful space, is what is the new cloud, the layer of abstraction we want that is fully general, and you can write whatever you want in whatever language, but is also high velocity for developers and takes away a lot of the pain that you don't want to deal with. And I think figurative and literally can fit in the middle here. And this is best shown by Kubernetes, which I'll talk a little bit about today. But there's other parts to it too. Containers give you packaging that separates you from the infrastructure. And Istio, which I'll talk about today, gives you a kind of control plane that you can use to separate operations. So a little bit about Kubernetes. In this context, I'm not going to tell you kind of how it works. I just want you to think about how it changes your abstraction. Right? What are the things you think about and don't think about because you have this layer? And in particular, if it's going well, you're thinking about the services and how you break your application into services, how you balance load, the names, the state management, where does the state go? How do you think about monitoring and logging and production and rollout and upgrading? Those are the right things to be worried about. You shouldn't be thinking about a whole bunch of stuff you historically have thought about, like which OS, what version, who patches it, how to package your software so you don't have conflicts, how big of machines you should buy, provisioning in general, your disks and all that, how to choose a language, how to mix languages, how to have different teams use different languages. All that should be stuff you're not worried about anymore. Right? And even if one that's always made me laugh, but we had to fix it because we got it wrong internally at Google, it's port conflicts. A machine has a set of ports. In Kubernetes, every pod has its own IP address, which means it has its own ports, which means everybody can have port 80. Right? It sounds like a simple thing, but it makes DNS work, for example, and it actually simplifies a whole bunch of stuff. So that's what I mean by a higher level of abstraction for Kubernetes. This is taken off pretty well. You might have heard of it, I suspect. PKS certainly is a great use of this. What I really just want to point out is that it's very broadly in use right now. Meaning I think people are finding it as a layer that they can actually build on, and thousands of projects are being built on it all the time in all kinds of areas. Right? Very broad set of things you can do with it. And it also has an incredible rate of change, which means that we were right to open source it in the sense that the number of teams and people contributing is huge, and the rate of innovation on Kubernetes is really unmatched. Right? Every 25 minutes, like halfway during this talk, there'll be another change probably that's been committed into Kubernetes. Right? That's a good sign of health for something that you want to build on in the future. Now, when I say the new cloud, what do I mean? Well, I mean essentially that it's kind of the set of things you're worried about, right? We're going to definitely leverage containers. That one seems obvious, right? They decouple applications from the OS and from library issues. Services are kind of our main building block. Right? They're the unit of deployment and the unit of upgrade, and in practice, the way I use them, they're the unit of teams. So the teams can have independent rollout timing, which means they don't have to coordinate quite so much, which improves their velocity. I think it's important that you mix languages, but not only languages, frameworks. Right? So you may have many frameworks you're using, Hadoop or Spark or Cloud Foundry or Lambda or anything from any multi-cloud provider. All those frameworks should be able to work together, right? Even for different languages. Then there's another aspect to it, which is you act differently if you're going to kind of own and operate your little service versus you're in an enterprise and you want actually developers to develop and operators to operate. So it's the decoupling is useful whether you're DevOps or you're separated, but I really want a separation of how we do operational changes from how we do what do we do in the software. And I'll talk more about this quite a bit because I think it's an important thing to get right. And finally, if we do all this right, it's a fully general thing. We can build all the things we could build before. They can have state or not, but now we're at this higher level of abstraction and we're all more productive. And finally, it's based on open source. Google's had versions of all the things here for anywhere from 5 to 10 years now, but they were all proprietary. And honestly, the new versions are better for many reasons. The main reason the new versions like Kubernetes and Istio are better is because they have community participation. Right? There are many other groups putting input into how these things ought to work, and that is super valuable. So given this kind of foundation, you can implement services, it turns out, in Cloud Foundry. You should do that. In Kubernetes, right, using its services, or even as legacy things on VMs on bare metal in the enterprise. Right? We're going to have services in all three of these kinds of environments. They're quite different. And we do it right, it should be easy to consume and create services across these environments. This is what is going to give us hybrid and multi-cloud. And I think the part you would probably recognize from this is Open Service Broker, which is a way to kind of find and deploy services in different environments. And I think that's a great piece. We're going to build on it. But the part I want to talk about today is Istio, because I think it's also important and it's less well known. So Istio, what is it? Well, it's a little complicated, but roughly speaking, we're going to proxy all your stuff. We can talk about performance in a different talk. We can make that work. What it's really doing is we take your service and we put an Envoy proxy in front of it. Right? That's a point of interposition, and one of those things from computer science is that if you want to fix your problems, have a level of indirection. Right? Well, this is a level of indirection for all the things. Right? But it's slightly better than that because it's a coordinated level of indirection where we can have policies applied across all these proxies that are uniform and can be upgraded dynamically. So for example, if you want to make an operational change on access control, that's implemented by the proxies and can be deployed instantaneously, independent of the services. In fact, the access control is now completely independent of whatever services you're doing, and more importantly, it's completely independent of the source code that developers work on. Right? Which means that when you want to make a change for policy, you don't go look at the code for the service. Because if you have to go there, you're going to have a hard time changing it, because you're going to have many services with many different rollout timelines. So we're going to put these layer proxies in, and they're going to provide a whole bunch of benefits for us. So for example, just on the basic data path, we're going to authenticate all the services to each other. So when you get a request from the front-end service, you actually know it's from the front-end service. Right? This means you don't use network firewalls to do this, and you don't use user identities to do this, like running as the front-end user in Unix. Right? That's a common pattern. Not as good. Right? Here we're authenticating the service, not the employees. It does simple load balancing. It does health checking, all the things you'd want a proxy to do. On the control path, which you can think of as the start of a request arrives, what do we do with it? Now we can do access control, and it can be based on layer 7, layer 4, identity, whatever we need. It's also how we enforce quota, if you want quota for certain other services, or rate limiting. If you want to collect data, like what is the actual SLO delivered for this service, we can do all that telemetry in the proxy and tell you for every service with no service changes, what is its actual latency profile. And finally, you can get some quite fancier load balancing or even API management. Right? But I think the meta point here is the decoupled operations. None of these things, which are all useful features, are in the source code. which means that if you have an operational team, they can change these things without having to interact with developers. Maybe they'd like to, maybe they wouldn't, but they don't have to, right? And they can deploy changes instantaneously independent of services, right? So the way this works is you have to have a service management layer. In Istio, this is called the pilot. And you can think of it, it's just being a little centralized thing that deploys configurations to all the Envoy proxies. So this is what gives you uniform policies. If you want to change the access control policy for all the services, you change it at the pilot, it gets rolled out to all the envoys, and now you have a new uniform policy across all your services. It turns out it's pretty well integrated with things like Kubernetes, so if you push a new pod or create a new service, it'll actually get set up into Envoy automatically, and the pilot will know about it. I believe the same thing will end up happening for Cloud Foundry services. When you use Open Service Broker, this is actually how it gets deployed. It's part of setting up the Envoy for it. And finally, I don't want to talk about it, but there's a whole auth layer where there's an auth thing that actually manages keys for all the services and makes sure that, service A calling service B, they know each other's keys, and they can validate the traffic as expected. So when you combine these together, what you get is you can write your services in Kubernetes, you can write your services in Cloud Foundry, or even in some other system on-prem connected by Apogee or however you like to connect legacy services. And then the Istio service mesh ends up being the thing that gives you a kind of uniform view, a uniform control layer of all these different services implemented in different environments, right? And so Cloud Foundry, Pivotal, Kubernetes, Google, there's a lot of people working together on how to make this layer in this picture work exactly the way you want. And it's a place of great leverage. Now, it turns out this also ends up being very useful for hybrid and multi-cloud. And so let me just talk about the kind of strategy in the new cloud for hybrid. There's still lift and shift, and that's a fine hybrid strategy in general, but that's not the part I'm going to talk about today. What I'll talk about today is you're trying to modernize your infrastructure. You might want to modernize on-prem without necessarily having to move to the cloud. That's, I think, particularly true in this room. So how do we do these things where we want to span multiple clouds or span on-prem and cloud? And it really has two core ideas. The first one is that if you want your applications to run the same in different environments, you really need to have consistent source code. And the easiest way to have consistent source code is to have the code be open source. Right? So foundational to our support for hybrid and multi-cloud is to say, let's take the core pieces, which in my mind, at least for the three obvious ones, are Kubernetes, Istio, and TensorFlow. I would put Open Service Broker in that as well, and several other things. Those pieces, because they're open source, give you a consistent environment just by being the same. Right? And they'll stay the same because they're actually, as they change, you're getting the newest versions on all the platforms. The second aspect of this kind of hybrid strategy is that you have to use services as your unit of partitioning, by which I mean when you say you're multi-cloud, what that would mean here is that you have some services running on this cloud and some services running on this cloud and some running on both. Right? And it turns out the service broker and the way Istio works is that's very easy to do. Right? You can mix and match services quite well. And it actually kind of gives you a best of breed. If there's some service from a cloud that you really like, you can mix that in. Right? If you want to have your own core service for say, user management, you can run that as a service on all your environments and share that code. Right? So this actually is, we have customers already doing this now, and it's a really pleasant way to do hybrid and multi-cloud. And if you use Istio, it actually makes this quite a bit easier, in part because you actually get a uniform view. Right? All the service telemetry of all the platforms can be viewed in one place. So what does it mean to move to this higher cloud? Well, I think you already know in some sense, Cloud Foundry users live in this world partially already. I'm just trying to broaden it, make it complement it, I would say. So obviously, we want a higher level of abstraction. We want it to be open source. We want multi-language and multi-framework, right? Full range of applications. Anything you want to write should be expressible in this new cloud. In turn, with both that higher level abstraction and the decoupling of operations from development, you should have higher velocity. And that, in turn, gives you also a better answer on how to do hybrid and multi-cloud. So to wrap up, I have one last little announcement. This is kind of fun, which is if you use Pivotal Container Service or Cloud Foundry, we're going to give you cloud credits to try them on Google. And you don't have to do anything. Pivotal will set up the environment for you on GCP, and you'll get credits from us. This program is still, I would say, fresh. So if you want to follow it, just ask your Pivotal rep, and they can explain how to do this. And then you can try your own mix of all these services. And any of the services on GCP are available through this program. So whatever you want to try and mix and match in will just work. All right, thank you so much.